Okay, hi everyone. Welcome back to the Perception Action Journal Club. Back joined by Andrew and Marianne to continue on our journey through Turvey's lectures on perception. We're right. We're doing chapters 11 and 12 today. I believe that's correct.
Oh, good. That means I read the right ones. Excellent.
What's that?
It means I read the right ones. Excellent.
I read ahead last time. I read 10 and 11 last time. So we're getting right into the heart of indirect perception. That I would think it would say this is still the view of indirect perception that exists today. We get into we'll talk about there's Bayes' theory, which is the dominant. I would say. We're getting into Helmholtz, some good stuff here. So we got a couple chapters. Separate these. The first chapter is another space enigmas on learning. Oh no, that's
the second one.
Second one, he's going to get into how unpayable loan on intelligence it's required for. So the first one just introduces unconscious inference and basically Helmholtz's ideas.
Right.
And so I don't know. So and also we're going to get a little bit of neuroscience here too, a little bit of just the kind of logic that pervades a lot of neuroscience, the fMRI, the idea of specific nerve energies, that there's specific neural responses tell you what you're sensing based on what pattern or what neuron or what pattern of neural signals pick it up.
Yeah.
Yeah. So there's
and those different, the sort of first, second, and third grade sense. I think that was quite interesting.
That's coming back. Yeah.
Yeah. So I guess the Helmholtz's fundamental idea, right, is that as I said, it's still the dominant, is that the senses we get are ambiguous. They have the sensory information we get from our senses is ambiguous. It has no meaning to it. You have to add meaning somehow through the process of perception, which he argues is kind of a back hypothesizing, given this set of stimulations, what is out there. That's his basic idea.
Yeah. And it's funny as well, like, just to note, like, Turvey notes this, but it was just like, this is, Helmholtz was a long time ago, 1866, right? But this is the core, right? If you take a sensation perception class, this is what you'll get taught about sensations. And like, this is just it. So, like, I remember learning about specific nerve energies and people going, wow, isn't this amazing?
Yeah.
Like, it's been a while since I've been an undergraduate, but even so, right? Like, just, this is like, and again, it's just interesting just to note that this, Turvey's talking about all these things, and we still haven't made it really to the 20th century.
Yeah.
And yet we've basically hit modern indirect theories of perception.
Yeah, this is we haven't really moved.
Yeah,
the details we have, but
Helmholtz is literally one of the key frameworks for the free energy principle. Right, like, quite up front, right? Like, the people have put an embodied spin on it. People have tried to give it an ecological kind of flavoring, and this is one of the weirdnesses about the free energy principle, is that you can cast the whole thing in a bunch of different ways. But Friston's a bit slippery about which one he actually endorses. But basically, like, free energy principle stuff, cutting edge neuroscience is literally and explicitly Helmholtzian, right? Like, the free energy principle is a hypothesis about how unconscious inference works.
Yes. And Bayes' theory, they're all just different variants of the same idea. This is one of the most important ideas in perception, I would say.
Yeah, absolutely.
It sounds simple now, but it was really kind of going beyond some of the previous ideas. As we'll see in next chapter, it doesn't go as beyond previous theories as Helmholtz would like to think, right? Because it's still he wants to present it as a purely empiricist view of perception, right?
Right.
you build up your this hypothesis process, the perception process develops through the experience.
Right.
Your experience you learn how to interpret the sensations, right?
Yeah, and how you link these things together and how you learn to associate the two and that sort of stuff. And it's just the same old problems.
Yeah.
Just written by a really super smart guy, right? Like Helmholtz was literally just one of the smartest people ever to throw himself in this ring, right? Like he did all kinds of stuff, right? Like he wasn't just perception. He was doing physiology, psychology, biology, you name it. Like he was, by all accounts, he was just a super smart, fully engaged human being, right?
Yeah.
But he's just operating in that same Cartesian framework. And so like he ends up coming up with sophisticated solutions to insoluble problems.
Yes. Yeah. And I guess while we're on the current, I guess the new twist on the Helmholtz is the adding in the prediction stage, where you're trying to predict the sensory feedback you would receive, given and making an action. That's kind of a new twist on his. He didn't have that in there, but he's just talking about truly. And a big thing that will be made throughout this is a big case for unconscious inference and indirect perception is always illusions, right? How can you have direct perception and get it wrong, right? Is the fundamental argument. And so that's always put forth, which in his theory of fully explains, right? You got your hypothesis is wrong. Given the set of stimulation you had, the perception that the Muller-Lyer illusion, the lines are different lengths, is fully reasonable given the pattern of stimulation you have, but it's wrong, right? Not what is actually out there. So how about the doctrine of specific nerve energies? That's basically the idea that we have cells or structures in our brain that respond to very specific stimuli, and each stimuli is going to give us a different neuron's going to respond, or a different pattern across a series network of neurons. Is going to be a unique brain signal for every possible stimulation.
So I think, I was just going to say one of the examples of that is if you rub your eye and press on that, then you get flashes of light. And the idea is that you've triggered the nerve, and the only way it knows how to respond is as if some light had stimulated it, for example.
Yeah, no, I was going to say there's what they're bringing in here is that some of the changes in just in being able to view things like microscopic detail to see nerves and fine nerves then sort of changed. So as our technology improves, now we start to get changes in maybe the details, but the basic concepts, I say, haven't really changed. I was interested in the difference of the idea that I think Helmholtz talks about the fact that it's there's that specificity of the nerves to one bit. So many, whereas I can't remember the name. I haven't got the notes. I can't see it while I'm watching you. Someone beforehand were saying it was more like a palette, and you can mix and match them. So you could have this infinite amount of variability, because the main thing is that what we are able to pick up is so small and impoverished compared to what's actually out there to be perceived.
Yes.
So how do the nerves manage to gather that information? And what I understood, one of the things that Helmholtz was saying was that there was this almost like back to that mechanistic thing. The specific nerve will have a specific thing, and they're not. Yeah, I thought that was quite interesting.
Yeah, and then there's a bit of a discussion about whether percepts belong to an when they get into illumination, whether what kind of belong to an object or not, sort of.
Well, color was the first bit, wasn't it? And being colorblind, I always find that fascinating. That there are things I can see, and I'm like, I say this is red, but am I seeing what other people? I know I'm not seeing what other people do because I'm colorblind. And I still think I see this rich and colorful world. In fact, so colorful sometimes that I think, God, it would really drive me nuts if it was any brighter. Which is interesting, isn't it? I don't think, I'm going around in this gloomy, colorless environment. But that's fascinating. That the property of something that's red doesn't change just because I've looked at it.
Yeah, I like this because the one illusion he mentions in this chapter, Alan Gilchrist. When I was a postdoc, I presented in Canada, York University, and I saw this demo live. It's one of the most impressive demos. So basically, I can't remember which page. I think it's chapter 11. Talks about the lightness demo. So he starts with a panel, and I like this because it's not on a computer screen or projection. It's a panel, and he illuminates with a light, and you're like, what color is that? So what looks white, brightest white you've ever seen. Then he puts another panel, and that one you just thought was white is now gray. And he keeps moving on, and eventually he turns on the lights, and the first panel that he lit up is black. Because the point is, what you perceive the brightest thing the thing that gives out the most illumination in the room is given assigned white, right?
Mm-hmm.
It's not actually white. So it's very, I like that. This is a tricky thing for, inferring. Like, I guess this is where we get in the purpose of perception, right?
Yeah, I was just thinking that.
We're changing the goal of perception is to recreate understanding of things and objects, right? Whereas,
and it's also about the idea that perception is about or is based in the basics of physics.
Yes.
Rather than sort of the ecological scale reality. So the idea that it seems really intuitive that the intensity of a light should correspond to whatever, its color or whatever. And the problem is it just doesn't. These things fall apart. These, they talk about a specific example of, this particular relationship that just doesn't hold, even though the physics is really straightforward. Perceptually, it's just a mess. And again, it's just kind of these are always sort of seen as problems to be solved rather than a hint that the theory has started in the wrong place.
Yeah. I think that, the classic, it gets into more chapters, like when an object's size on your eye changes size.
Yeah.
Right? In the Helmholtz view, that's it. There's ambiguous, so you have to do this kind of legwork. What happened? Whereas in Gibson's view, you're using the wrong information. You're starting from the wrong point, right?
That one's a good example as well, because Gibson's, I can't remember if it was his PhD, but his first published work in the late 20s was literally on the relationship between what's on the retina and what's in perceptual experience, and finding that they bore no relationship to each other whatsoever. What was going on the retina in terms of the shape of an object, for example, simply had no correspondence in perception. And that was the trick with Gibson was instead of trying to tweak it and, find a little process that would save it, he went, and kept trying to push it, right? And that was kind of the beginnings of him just going, and trying really hard and rigorously and failing to get something like this to work.
Yeah, we're getting into another important concept, the perceptual constancy idea, right?
Yeah.
Yeah. Go ahead, Mary.
Oh no, that was just the bit I was thinking about there before we get into some of the other bits. That the link between what you perceive now and the past. It was that sort of constancy, was that nested. That is another thing that needs to be almost taken into consideration. For learning and perceiving. He almost drops this hint that is not only going to dismantle space and space perception, that time is also going to come into the picture. That's the bit.
That's a good point. Yeah.
He drops this little hint in that it's going to start changing the way we think about time and what an episode is and how you bound time in perception.
Yeah. And what counts as the present perception.
Yeah. He just hints, doesn't he? I was really interested. I keep thinking as well. I was reading. I found 12 easy because it started telling stories and talking about animals, which always makes me feel much more comfortable. But 11, going through it, thinking, I'm sure this is going to get easier. I'm sure this is going to get easier. And I start thinking, he's just dropped another little hint in and another. Yeah.
Yeah, this is very much a static snapshot. Your perception, right?
And this is what he's going to move away from, isn't it? This idea that you're seeing something static.
Yeah.
in a moment in time.
And literally, like, so on page 166 and chapter 11, right, the doctrines of sensation, he gives a list of what sensations are.
Yes.
You know, and so they're discrete, they're momentary, right? They're transient and ephemeral. They're integrable. You can combine them, but you have to combine them because they are not themselves combined. They don't present themselves as combined. Immutable, irreducible, all this kind of stuff. Like all those elements are just it's the and Helmholtz is coming at this from, he's beginning with the physiology of the retina, right, which is the other big move that everybody makes. And again, it's not a stupid thing. Like you go, right, where does vision begin? Well, vision clearly begins in the eye, right? Mm-hmm. Let's have a look and see what the eye is up to. And you know, that doesn't, like, that seems like a perfectly sensible place to go looking, and it's, which just makes it even weirder that Gibson ends up going, do you know, like perception actually, like perception is up and running and happening by the time light interacts with the goddamn thing, right? So, and like that's the weird thing. But if you start with the physiology of the eye, you know, you just end up, it just looks like, you know, like a little digital camera sensor, right? Like it's isolated, it's discrete, it's taking images, it's et cetera, et cetera. Like if you just look at, if you start there and then try to figure out what it has access to, as opposed to the other way around, then, you know, like you're looking for the pieces.
Yeah. I think the camera, I was going to mention that, you know, the way you typically teach visual system is you compare the eye. Their eye is very, very similar to a camera in many ways, right? It has a lens system that can adjust to keep things in focus at different depths. Mm-hmm. It focuses the light on a photoreactive surface, film in a camera. Right? And so we look at the film, we look at a film and we interpret it. So why wouldn't you do the same? It makes a lot of sense in terms of the most advanced technology of the time, I guess. That's a, but yeah, it creates a lot of the constancy one. Like, so if I take my phone, right, as I move it away, its image gets smaller. If I slant it, all these changes, and yet it's the same thing.
Yes.
Right? So perceptual constancy is this idea, and I've never been satisfied. I went down this road when I was first started grad school. It's never a really satisfying explanation of how you do this.
Right.
You somehow have to perceive the distance of the, you know, and that's where you get illusions, right? When I misperceive the distance, I misperceive size, and then my constancy mechanism doesn't work. And
it's like the classic Father Ted joke, right? They're sitting in the caravan.
Far away.
This cow, you know, this is small. That one is far away, right? But that's the shape of the problem for Helmholtz, is that there's a confound that needs to be resolved by some process that is integrating and inferring and has baked into it some rules so that you know how to take all these into consideration, right? And so the idea is this is just, you know, Helmholtz is doing his best to have a really clear articulation of the problem facing the visual perceptual system based on, you know, the analysis of the retina in this case, and also just thinking about other things, you know, like Kant was coming at it from these sort of philosophical reasons. Helmholtz is living in that world, but he's trying to come at it with physiology as kind of his basis, because he wants to, like, this is the reality of the structure of the eye, so this is probably what we have to work with. Let's take that seriously. It just causes chaos, right? Like, it's just, you know, like, where do these rules come from? How do we infer all this?
I think the other bit that you were talking, that the illusion where, you know, you've got these progressively lighter squares, and then you see that the first one was actually black. The light box. I mean, that I hadn't heard of that before. You know, there's nothing reflected. It's black. It's like space. It's just black.
But it's full of light.
But it's actually full of light, but you have to put something in there for it to reflect off, for it not to just be dense black. But I hadn't. Well, of course, and it was one of those things where I thought, well, that's why it's like that in space. But I haven't really thought about it.
Well, but it's really important. But it's funny that it took an empirical demonstration, really, when you think about it, because, you know, Turvey points out, look, if we could see light, then you wouldn't be able to see anything, because we are completely surrounded by light, right? And so we can clearly see through light to things. Like it's just active experience. But it's interesting that, it took this, this empirical demonstration, and then there's that, then there's the whole thing, the astronauts out in space, right? What's their experience of space? They're looking around, and what do they see? Blackness. What are they surrounded by? The light of the sun, right? And I think about this example as well. Like, spotlights are a great example of this, right? So like if the, or a projector in a movie cinema, if you look up at the projector, you can see the light coming out of the projector. And if you look at the screen, you can see the light on the screen. But if you look in the middle, you can't see the light unless there's dust or something all over the place. And what do you see? You don't see the light, you see all the dust, right? And it's funny to me, I was reading this, and it's just one of those things that's such a fact that it's kind of weird that you pointed out and note that it's quite important. But it is really important because the whole Helmholtz thing is that the raw material for vision is light. And light energy and light intensities. And that's just clearly wrong. But that's, to
me, that's really because it's Gibson's central doctrine is right there. We don't perceive light, we perceive how light is structured meaningfully by objects and events and surfaces, right? That's what we perceive. That's his central idea is right there, right? But
so there's Turvey highlights where I'm just trying to find it. Gibson makes there's a nice distinction. Where did it go? That Gibson makes between seeing. Hang on, let's see. So Gibson makes the distinction between the energy of the stimulation versus the order in the stimulation, which is effectively the distinction between light and information in the light, right? And it's funny that no one else did this. Everybody's trapped on the building block of vision being the energy of stimulation.
Even when you start, I remember, even when you start from the simplest thing, like illumination, the amount of light coming off a surface is incredibly complicated. It gets incredibly complicated really quick. The definition of how you measure and quantify illumination, it's a different way. It's very complicated. That's the most simple thing you would think. We stumble right from the start, out of the gate. I like that. That was a good example.
Snoopy agrees.
Rand's got a guess. That's okay. Keep us on our toes. Yeah. I think from chapter 11, is there anything else?
Well, so the other thing that's in chapter 11, Turvey doesn't refer to it by name, but there is lurking in there the notion of psychophysics.
Yes.
Right, that there is physical stimulation, there is the psychological response to the stimulation, and that the job of the perceptual psychologist is to study the relationship between those two things. And so, psychophysics is a Helmholtzian invention, pretty much, and some others as well. But and it's the central method for perception studies for the next, from whenever it started till now, right?
Yeah, and I think, Claire or Michael's done a good job kind of discussing, so psychophysics is trying to relate the physical to the perceptual. And Claire points out, we have no access to the perceptual.
Right.
You're doing a post-perception judgment.
Yes.
Right. That's something she hammers on about, but yeah, you're right. That becomes, and then we get the develop of the psychophysical methods, the method that you learn about if you take perception, method of constant stimuli, method of limits, all those kind of things.
Yeah,
like again, they're still used, right, in standardized testing.
It's complete. Yeah, it's completely standard, right? You get a version of this when you go to get your eyes tested, right? When you're looking, it's as they go through the different lenses and get you to go up and down the difficulty. Crudely, it's a crude psychophysical staircase procedure, right? And the idea is they're trying to hone in, bounce around, and then figure out where you are, right? And people
every type of standardized testing, the LSAT, GRE, that they all use the same. this was very, very important work. It's lasting for a long, long time.
I'm trying to think what else stood out in that chapter, because I think my understanding in that one, and then which was kind of, I saw again in the chapter afterwards, he's trying to move away from this idea that there's this, that our experience, we have this set apparatus, even if it's the neural system that perceives something and then something happens, we embellish it in some way through learning, that actually that whole system, which we're going to learn in the next chapter, is really not that simple.
Right.
And he does allude towards the end of this chapter when he's saying there's this perfect, this matching, the way in which they, historically we've looked at nerves being this second a bit of this connection.
But no, you're absolutely right, because the next chapter is literally all about, all right, as soon as you start to poke this, all hell breaks loose.
And then I went, "Ooh, this chapter got interesting." Very quickly.
Because I think, going back, Helmholtz's problem was he didn't like the kind of the requirement of some gift from God to perceive.
Right.
He wanted a purely empiricist view of perception, that you learn through experience. You learn what this pattern of stimulation means. This pattern of stimulation means that, and you build this deduction. Or I think
there's the three different
abductions.
Was that chapter before the three different?
I think it's
ways
the second one, the 12.
Yeah.
And so that's what he's trying to do. And in chapter 12, Turvey shoots it down, shows he didn't do that at all.
It just turns out, like, this super smart guy who's trying to tell the story apparently didn't notice that about 3 really important loans of intelligence just snuck in there, because they had to be in there somewhere, and they get in, and then all of a sudden that's where the magic happens. And so it's worth, in some ways, at least the people who, like Berkeley and some of the others, at least they knew they had loans of intelligence and that they were on the hook for them. And they tried to come up with solutions to them. And even if that solution was God, some of them tried to come up, some of them tried to naturalize it and make it, well, evolution builds the intelligence in, or whatever. But it's while you were talking, it just seems that, like, Helmholtz is pushing to try and develop this notion of perception where it's all in the learning of how to associate these things together. And also talks about and refers to things that imply a loan of intelligence, and doesn't seem to notice that that's what he's doing, and therefore doesn't realize he's on the hook for them, and therefore doesn't try to explain them very well.
It's a little bit like I've heard you, Rob, talk about that, just shuffling the box under the table. Just kind of moved it along a little bit and then moved it out of the way. Steps in.
And you know what? It's funny, right? Helmholtz is sitting at the bottom in the core motivation of the free energy principle, the coolest, sexiest thing in neuroscience, right? And it's just like, look, it really is just another example of the same old. Like, how do you solve this problem? How do you solve that problem? They're not talking about how you solve those problems. They're just giving them new words.
The fundamental idea is, the basic idea, the loan of intelligence is, right, if you assume that you need experience to interpret sensory information, where do you get that experience in the first place? Right? Because you can't interpret sensory information without experience. Right? How do you ever,
And he alludes to some of it being, well, we've evolved to have that already, so we've got that experience built into our
down.
And then he completely bombs that in chapter 12. Anyway, it's not that simple. We might have apparatus that is attuned to specific forms of information, but there isn't an automatic one-to-one relationship.
He's looking for invariance in the wrong place, right?
He gives lots of great, I'm sure you appreciate this, Mary. He gives lots of great animal examples.
I know, I loved it. It was right in my element.
A whole section of how if you take certain experiences away, like the other big thing he pokes at is, what does experience mean? Anything? Or is it active experience? And he shows lots of great examples of very specific experiences taken away that completely change.
That would that you would never guess.
Yes.
Would be links. That's the key bit that somehow, and again, I think for me that's interesting. Somehow in our evolution, it's a little bit like why our knees are really not well designed, and our eyes. There's all these things that like we have evolved through various forms in various environments, doing various things, and there are probably things linked together. The snakes and the eating insects and then recognizing snakes is one. You just go, how does that link? You would never guess that those would be somehow something that's really important. But it really made me think about how, and I think this just in, coaching children today, when you start to really change the experiences of a species, any species, including humans, in their exploration and the enriched environments they're engaging in as youngsters, and we have no idea what that impacts that have, because these are just not obvious links.
It's funny, I like that as well, that about the obviousness, like this notion that when you're coming up with your theory about how experience works, it's like, well, look, you just figure out what's necessary. Like what makes good sense? What are the kinds of things that are obviously required for you to be afraid of snakes? And what's his name, Gottlieb,
and he's like, you do
experiments, right? And just pointing out there's a lot of stuff that seems weird from our point of view. A lot of it is in the mix because for whatever reason it's something that is reliably present in their evolutionary history. There's a phrase for this. I can't remember what it is. I think it's like evolutionary stable strategies or something, where it's like you don't, it's a replacement for innate, and it's like you get something that looks like an innate behavior, but what it is really fast learning in the presence of stuff that evolution has been able to take advantage of because it's reliably present in the lifespan of whatever the animal is. And it just so happens that it's because it's reliably present, you're able to take advantage of it and use it as part of the context within which, and that learning can be super fast. And so it looks like it was just previously there, but as soon as you poke it, this was the thing. It's like, all this stuff that looks innate, like an innate fear of snakes. It makes sense that you're innately afraid of snakes if you're a squirrel monkey. Well, it's like, actually, no, you have to learn that. And it's weird how you learn it, right? Like you have to eat insects before you're afraid of snakes. Like, what the hell is that about?
As a baby, you have to eat insects.
But
the chicks having to see their toes, which look like mealworms, is a little bit more, you can kind of go, okay, that seems a little bit more obvious, and kittens need to have light within a certain time for their, you go, those ones make a bit more sense. But
as far as human beings, like the experience, we teach, like, you need to give kids a varied environment, right? That's why we use mobiles with all the patterns and the color. We need to, interacting with the object, but again, it's not, there's no specificity to it. Like there's no, to learn, even I think Turvey goes into the size, distance, and variance again. To properly learn that would take quite a while of stimuli to learn that relationship to be able to create a proper prior for.
It just really made me think about Helena Gibson's work as well, and Karen Eidos now, the stuff that they do, and this, the way in which baby animals, including humans, touch, lick, the horrible thing that kids poke their fingers in sockets, anything, eat things, that active engagement, exploration in their environments that, as parents sometimes we're horrified at. And anyone who's had other baby animals, horses, dogs, they all do the same thing. Babies really explore, can I eat that? Can I touch it? Can I sit on it? Can I poke it? Can I? They really, and it just made me think about how important that is. And we don't let baby horses do stuff generally.
Right.
We think, I say we think they're going to be able to notice the affordances when they've never been in an environment and they haven't had the agency to explore.
Yeah. Well, actually, while you guys were talking, it was occurring to me that all this, the things that count as experience required to learn something, and the fact that there's so much of what's required is non-obvious to us, while you guys are chatting about that, it occurred to me that has immediate implications for anybody, for coaches, for anybody training anybody. Because what are you doing? You're trying to create an environment in which learning can occur. And if you start with nothing and then start adding things in, you're only going to add the things that are obvious, right? And then the question is, well, maybe those aren't actually, maybe you're missing some stuff. Whereas the more ecological representative notion is to start with the whole context and keep as much of it as you can, but then constrain it in various ways. And so one of the things that you get is a messier learning environment, but it could easily be the case that some of that mess is actually not incidental, that it turns out to be something that the whole thing is relying on, because that mess draws a contrast or guides attention or what have you. And I'm thinking about it in the context of using virtual environments for training as well. So my PhD student's busy writing up his work at the moment, and virtual environments have all this promise because you can put whatever you want into them and you've got all that control over them. But of course, the only things that are in the virtual environment are the things that you think to put in there. Yes. And so again, the power of VR is you can put a lot of stuff in. The risk of VR is that you have to know what to put in. And so what do people do? Well, they try and put things into these environments that they think matter, but by definition, they're only going to put the obvious stuff in, right? Mm-hmm. If you created a virtual environment to try and teach a spider monkey or a squirrel monkey to be afraid of snakes, you would never include in your training environment the eating of live insects, right? Yeah. But if you put them into a context in which they might encounter a snake while they're doing some other stuff, eating a live insect is the kind of thing that might happen to them, because they will get hungry and they will munch. And so, it's I think it has all kinds of interesting implications and connections to the underlying motivations and the concerns that we have with the kind of training environments that people put people into and animals into as well.
Yeah, I think we're seeing something we don't usually talk about on the perception side. We usually just talk about it on the action side, is complexity and non-linearity. Right, of learning from perceptual information. It's not. That's what you're seeing with those animals. It's not simple, predictable from the inputs you're giving them in the terms of what they're perceiving. Yeah, they're learning. It's complex.
And it starts before birth, know, and it gave some great examples there of the fact that this starts, and then he starts to get into it. Actually, starts to change your DNA, that they're all interacting with each other, which is which kind of makes sense, because as species we need to be adaptable. So of course, all that is going to be built in. But some of the adaptability, obviously, is, like you say, it's connected to things that we just wouldn't think it is. But it also made me think again about the time. Again, he's sneaking in this concept of time back into this chapter that he's not doing, as we now understand Turvey, he's not doing it, obviously. He's not shouting about it, but he's sneaking time back in, and these nested time scales. And again, even in environments, each individual that comes into that environment is going to have a very different experience that will have shaped their perceptual acuity, the perception and the way in which they're interacting with that environment. So you might create one environment, but those individuals, like the animals, are not going to necessarily be attuning to the same information. And I found this has been easier to explain when I talk about things like paddle sports, perhaps. When you say somebody who's a complete beginner looks at a piece of water, they're just going to go, that's just moving water. Mm-hmm. Someone who's a really experienced paddler is going to see a path, a route, a playway, an opportunity to stop, spin. So the information that is out, the visual stimulus is out there, you would say is the same, but actually what they're perceiving could not be more different.
Yeah, exactly.
Yeah. And that's an easier example than like looking at a footballer on a pitch. Everyone thinks, everyone's seeing the same thing, but they're not.
Yeah.
That's also gets reflected in language sometimes too. I was just in Ireland, and where our guy was talking about Irish. And he was talking about in Irish, there's 20 something different words for a field. Right? They're more sensitive to the information we're like, that's a green square of grass. They see much more information, and they talk about and you have people for snow. There's lots of
and as a climb, somebody who climbs, I don't know, I think that there's loads on there the Eskimos have, but we still talk about things like rime ice, growlpool, the wind slab. There's a whole load of different, because they all have different affordances. levels of safety.
But that's the other thing, of course. What is the, language changes and evolves to serve our needs.
Yeah.
But there's a sense that this gets back to this notion of what counts as an obvious feature of experience. There's a trap you can fall into if you're a skilled language user, namely that, well, I can describe a perfectly coherent chain of events or set of things required to do X, Y, and Z. But what you're actually able to do is enumerate the things that your language is capable of expressing, and your attention has been guided to those. And so the language is actually acting as a constraint on your ability to notice what's relevant, right? And so, but there's a trap you can fall into where you feel like you've given it a description because you've been able to do it using language and you've been able to articulate it and so on. And then someone like Gottlieb comes along and says, well, actually, yeah, I blocked off vision of their feet for 20 minutes and it screwed the whole thing. And it was like, and again, so I always think about, a big chunk of what Gibson did and what a lot of people like, I do this in my work, and I notice like the whole sort of field, this is one of the really useful features of an activism as a field, is that they've spent a long time figuring out ways to articulate things differently in a way that accommodates the things that we need. So they're good at talking systemically, and they're good at talking non-linearly, and they're good at talking in terms of the sort of the whole general mishmash of these more complex systems. But it took time and effort and purpose to drive the language to articulate these things so that we could then talk about them, at which point they then become the kinds of things that you can study. So there's that was one of the other things that was coming up, was just that trap of like, well, I can talk about it, so it must be right,
Yeah, I think you get the opposite too of it in ecological. Sometimes the wishy-washy-ness of certain word, like attunement, means certain people, we don't understand what's going on. That's people, because you can't specifically define the mechanism involved in attunement.
Well, and people get grumpy about the vocabulary they have to learn.
Yeah.
Right. So, you're using all these novel words, and it's like, well, we have to.
Yeah.
And if you want to engage with us, you're going to have to at least learn how to speak the lingo.
Mm-hmm.
We've had
this actually an important part of that.
Yeah, sorry, we've talked about this before, haven't we? Because I think it's not words. I think it's that it forces you to think differently, because the words aren't as hard as, I don't know, learning the Latin names of muscles.
No, yeah,
and things. They're not, in the grand scheme of things. I think that the words disrupt and perturbate the way you think.
I agree.
That people don't like, not the words. I mean, attunement isn't as hard as Latimus dorsi.
But it's an important part of it, right? Because this is all, like, again, Helmholtz spent all this time and effort coming up with this very detailed and elegant and very, theory that's had a century and a half nearly of impact. And he was doing it within a vocabulary set in some ways, right? And he was constrained by the physiology that he had. And he was constrained by the language that he had. And constrained by the vocabulary that all the philosophers we've been talking about in the previous chapters had provided him with, all the verbal analysis of the problem to be solved. And on the basis of all of that, he did something really sophisticated and interesting. And but it lives within this space, and all the evidence is really starting to mount now that actually the space is a whole different shape, and the words that you're currently using to describe it are simply the wrong words. And
just last, I know it's not in the chapter, but just thinking about the thing around perception, and I know Rob, you talk about the complexity of it, and I don't know if it's a thing, this idea of like you've got degrees of freedom and within visual perception as well, and you put beginner, and I remember being on a river, the Briançon Gorge, which is and suddenly just seeing this, I couldn't read anything. It's just like this overload of visual information. I knew the paddlers in front of me were like, oh yeah, nice route down there, and I'm just like, whoa, I can't notice anything. There's and it's, again, those are really powerful experiences when you have them, and I think about ASM, and when they say, well, if you want to be able to gallop a horse fast, like go skiing and go ride a bike, like pick up information fast,
right,
in an environment, because actually that perceptual skill is, like that's, being able to notice things when you're moving fast in a complex environment is not just something that you just naturally have. Do you know what I mean? It's not.
And I was trying to remember, there's a couple of papers by Bill Warren in the late 80s about optic flow. And he was reporting sort of a series of experiments and starting out with very simple scenarios in which sort of, something important was kind of the only thing to be detected, and then adding in richness to that optic flow. And what happens is that, the sort of the traditional prediction is that the more information that's in there, the bigger working memory load you'll have and the harder the task will be. And it's the exact opposite, right? Basically, the more information that's there, once you can discriminate it and differentiate it, then it actually helps. It actively makes your movements better. It actually makes your behavior more stable. And the more impoverished, simpler setup is actually a restricted setup that gets in the way, that causes instabilities, right? And so this idea that simplifying these things down and trying to find the core of it is the wrong direction to go.
Yeah, for sure.
I did like chapter 12. I was back on more comfortable ground. Stories and animals instead of maths. And
yeah,
we got is that chapter? You got Bayes' equation right there.
There it is. Yep.
There it is.
179.
Yep. The central of most. The same. Obviously, it's just a sophisticated mathematical representation of Helmholtz's idea, Exacta's idea. Yeah.
Yep. And look, if you're going to do that kind of adduction and that kind of logic, then Bayes is the right way to do it. However, the question is that what you're actually doing?
Has anyone tried to, like in computer vision, or explain how you get what kind of training stimuli you need to get the set to create a perceptual system? I'm not aware of any. You know what I'm saying? Like, how much experience, what kind of experience do you need to create priors to make a Bayes system work? I'm not aware of any. I think people just ignore this problem for the most part.
I mean, I know there is kind of a knock on this field that everybody just goes, oh, look, if your theory doesn't work, all you do is tweak your prior, and you don't have to really account for that. The prior is just the given, And so I know that people do talk about that as kind of like a weakness of this approach, that the prior is allowed to do a lot of the work.
Yeah.
This is not being used though in, I don't know, in artificial intelligence or cybernetics. So they're not using.
That's a good question. It's not like the big large language models. None of that's got anything.
None of the ones that I know of are, and I'm like, why is that? If this is the answer to it, why are they not using it? Or are they, and we just don't know, because it's not to my knowledge.
Yeah.
Yeah.
I'm surprised someone hasn't tried like the random interactions a child does. What kind of prior would that create? Like I don't, I guess it's not a problem that people worry about. Like, you could just start with some default prior and just say, here it is. Yeah.
I mean, I don't know. Are there developmentalists doing Bayesian stuff? There must be.
Yeah.
There must be.
Everywhere. Yeah.
I only know examples like, I don't know, some of the cybernetics, which, we look at quite a lot because that overlapped with a lot of motor learning, motor control, so it was always, they're always swapping over, weren't they? But they're generally, even those self-learning models have got something in the first place. There's still a learning of intelligence.
Yeah.
Not just in the design, and in terms of, what they're sort of programmed.
Yeah. A lot of it is explaining very higher experienced people's, right? So in baseball, people have the prior, the game situation is going to be a fastball. Well, of course they do, right? But how did they get that in the first place? And how did that develop? That's the question we have. Like, where did that come from?
Well, right? That is exactly what chapter 12 is.
Yeah.
It starts with it. You could literally switch in and say at the beginning, right? Helmholtz says that you've got this prior expectation from previous learning about the fact that it's going to be a fastball next ball, and then the question is, how did you know that? Which is exactly the structure of chapter 12, right? Where he just goes, right, Helmholtz says you've got this, and it came from experience. Well, how did that possibly come about? And then the other question is, well, what counts as the experience to build that in the first place? Well, it turns out we don't even know how to articulate that.
Yeah. Then you still have the problem, again, newer theories are starting to get better at this, like the action problem. Right. So this is creating perception as kind of a categorization. That's this. Then what do you do with that? Right? What do you do with that categorization? How do you act on it? And it usually doesn't have any specifics relative to So.
And it's not doing things like eating insects and looking at its toes and listening to its neighbors chirping in the, all the things that we start to learn actually are really important. So. Is it worth just think about, so that with these pies, there's 3 different ways of knowing, aren't there? Is that the
induction, deduction, and abduction?
Abduction, that's it.
Turvey always has teaches me new words whenever.
I know. I got the dictionary out quite a few times, and
well, that's Peirce, right? I think.
I wonder if there's more. Charles Peirce is actually a kind of underlooked guy in the ecological psychology. Like Gibson built on a lot of his work, I think. But,
yes.
Yeah. So induction. Okay. What's our definition? Deduction is taking a set of information and coming up with a.
Well, it's the thing that the thing that to follow, right? That's the Sherlock Holmes. Deduction of Sherlock Holmes, right? Yeah. Sherlock Holmes makes no guesses. He accumulates information until there's one and only one possible solution given those, right? Yeah. And that's deduction. And then induction is what you do with statistics, right?
Yeah.
You measure a sample and then work your way out and make an inference.
Make an assumption about the population.
Yeah, that's one is white, that's one is white, that's one is white, and then you've seen enough, and then you go, well, all swans are white, right?
Yeah, until you see something that isn't.
Yeah.
This was the interesting one, wasn't it? The abduction. Yeah.
Abduction, inference from observation to explaining hypothesis.
So it's going from an observation to a fact.
Mm-hmm.
Right. So deduction takes you from a hypothesis through to an observation.
Mm-hmm.
Induction starts with a fact and takes you out to a hypothesis. And abduction starts with an observation and works out to a fact. And that's what indirect perception is. The observation is some intensity.
What caused the stimulation?
The stimulation. Yeah. And that's the kind of logic that you have to engage with, which also places constraints on what you can do. So, one of the reasons we do statistics is that we're having to do, in psychology, is that you have to do induction, measure a sample, generalize to a population. And so we do statistics because when you're doing induction, you always run the risk of being wrong because you haven't measured everything. And so the whole point of statistics is that it's a framework where if you start with your facts and follow this process, you can at least, if you follow all the rules and do everything properly, then you can keep the risk of being wrong under control.
Fairly low. Yeah.
That's the whole purpose of statistics, right?
Yeah. And you know which way that risk is likely to be, depending on
if you follow all the rules, right? But that's statistics is a process for trying to wrangle that risk, right? And so the Bayesian equation is a way of wrangling the risks of abduction.
Mm-hmm.
By accumulating information in a certain way so that you end up with the fact of what's going on out there. And again, the idea is that you start with your information, and if you follow this process and if you follow all the rules and do all the steps and don't skip anything, then the conclusion that you come to is warranted by the process to the extent that the process is able to do it, right?
Yeah.
But you still doesn't say anything about how you understand the information in the first place that you're using.
No, absolutely not.
And that's
That's what all the explanations of illusions are kind of in words, kind of very logical. Oh yeah, we as people in developed countries see the insides of buildings, right? They're kind of post hoc explanations. I know people have tested them and so in other cultures there's differences in cultures' perception of illusions.
Yeah, but some of them hold up and some of them don't. I think Taz Firestone had a paper out recently about some of this stuff, I think. and I think was finding that some of it just doesn't hold up as much as people.
And then we got a whole industry of whether illusions are resistant to actions.
Yes.
By Mel Goodale started. If I pick up the Muller liar illusion, do I show an illusion? If I make it out of wood and make you pick it up, does your hand get bigger for the one that you perceive? And that's a messy story too. It's not clean cut.
But
in general, I think you get different. I would say it's fair. I mean, sometimes they show up, sometimes they don't. But yeah. No, I think that's. Yeah, that's the way I usually think that. Though when you talk about them in class, they're usually kind of it gets into just kind of post hoc descriptions that make sense and seem logical.
They are expected things.
My neighbour came to take Snoopy for a walk because I've still got Snoopy, so like he's going to be really noisy if I don't just throw him out.
So while we're on that, let's give what is the ecological explanation of an illusion? Just for completeness. Andrew, you thought about it.
So,
why did they occur?
There's a couple, right? So there's a couple of good papers on this. So the Turvey et al. Ecological Laws paper has a section about misperception. And I think it was Rob Withigan and somebody else had a paper a few years back where they kind of reviewed ecological accounts of all of this. And I think the main thing that happens is that an illusion requires a trick usually. Like it explicitly requires somebody to try and fool you, right? And so actually, so my favorite example. An illusion is usually you've been given restricted access to the necessary information, or you've explicitly been given information that is incorrect, or calling it an illusion is a mistake. So the one Turvey et al. Discussed the idea of you have these sharks that can detect electrical fields of fish, and they use them to hunt the fish that are hidden under the sand, and they go digging where there's an electrical field, right? And so if you're an evil psychologist, you can get a little portable electrical field generator and bury it under the sand, and you can trick the shark into digging where that electrical field is. And so one way to think about that is that the shark made a mistake and fell victim to an illusion. That's one way to talk about it. And the ecological way to talk about it is it would have been a mistake if the shark hadn't gone digging where the electrical field was, because within the boundaries of its life, within the scope of its ecology, an electrical field of that type specifies the existence of an edible prey animal, right? And so what's happened is that you've, in the case of this case, you've brought something from outside the scope of that ecology, and you've inserted something. You've effectively broken one of the laws governing the shark's life, and you're able to. And this is why it's in the laws paper, because the notion of a law of physics or a law of nature, people, in physics they try to find laws that are true universally. But actually, there's places where even those laws break down. But the scope of those laws tends to be over quite a lot of space and quite a lot of time. The notion of an ecological law and the kind of laws that we rely on for perception and action to work is that they're laws, but they have a limited scope, right? They aren't true throughout the entire universe. They're true with a boundary. And depending on the size of that boundary, you might be able to cross that boundary, right? And so within the ecology of the shark, within the life of the shark and where it lives and the nature of everything that's going on, the presence of that electrical field specifies the presence of an edible animal. And by bringing in the electrical generator, you've effectively broken the law, right? But the shark has no way to know that the law has been broken, because there is no information that the law has been broken. So as Turvey says, it would have been a mistake if it didn't continue to dig. So all illusions are effectively examples of breaking the law somehow.
Yeah.
Right, violating the scope of experience of whatever it is you're trying to test the behavior of.
Are there any that could be, and I'm just thinking aloud and making this up, just famous here. So, for example, we know that our movement systems and the way we operate isn't optimal. We've evolved and we we connect, and and we've talked about some of those things, whether it's knees or our eyes, are there things that could be illusions, that it's simply information that it hasn't over time been important for us to pick up, therefore we it's almost like irrelevant, it's non-specifying information that might.
There has been for like illusions created by passive transportation. I've heard like vection.
Yeah.
Like when you're sitting at a stoplight, everyone experienced this, right? The truck beside you moves and you suddenly slam on the brakes because you feel like you're rolling backwards.
That's what I'm thinking of. Yeah, because that's not something we would have needed to.
Well, it's just, so actually, but that's an interesting case, is that within the lawful environment, global optic flow specifies self-motion.
Mm-hmm.
And so you just happen to be in a situation which can occur but doesn't normally occur, that your entire visual field is suddenly full of motion. And so again, you would be wrong if you didn't react to try and stop yourself, because all of a sudden you are being visually, the specification is self-motion, right? There's other information that might be telling you, but obviously in a car it's complicated, because when you're in the car, there's no sort of haptics and locomotion information. So if you're walking, you might be less susceptible to this global optic flow thing. Although that global optic flow stuff, you get like moving room illusions and stuff for postural control and all that sort of stuff. The visual information is really it's a thing that we clearly rely on pretty heavily. I mean, I was thinking about, there's Mac bands and things like that. You have the Herman grids, the other one, where you have like a grid of squares. If you focus on one intersection of these squares, you can see that there's just a white line there, but off in the periphery, it looks like it's filled in. And as far as I know, that's just a side effect of the wiring of the retina, for example.
Yeah, it's ganglion.
It's just, but it only shows up under abnormal circumstances. You have to have this perfectly tessellated array of grids, and you have to fixate your gaze and not move it and observe what's going on in the periphery. And of course, the illusion immediately breaks as soon as you move your eye to that location where you thought there was a black spot. It disappears, and so exploration immediately breaks the illusion. So you've got this thing. It's a side effect of the wiring.
Yeah.
And so in some ways, it's kind of a compulsory thing that we're susceptible to, but also it's instantaneously breakable, because just the basics of action and the way we explore things results immediately.
That's what most illusions remove information and give somebody instead invariance, particularly. There's no time. You're viewing from a very specific direction and distance. You're not exploring. As soon as you do any of those things, most illusions go away. They break away. Not everyone, but so you're created a very special situation. Yeah.
I'm trying to think of one that's particularly stable.
Can I go back while you're thinking about that? Can I back? The black, white, and grey.
Yeah.
Mm-hmm.
That in a way is an illusion, isn't it? But when I read that and thought about it, I was like, actually, it makes sense that we are able to perceive what's lightest, because that allows us to actually perceive our world. The way in which we would adjust to darker places. Or I thought about what happens when I'm caving and I'm somewhere and I'm trying to pick information up. That way in which we perceive that the way the light reflects, it makes we think the surface is light or white because it's the lightest, actually helps us navigate our environment.
So it's only an illusion if you think the goal of perception is to experience correctly the intensity of the light coming off the surface, or
to get information for movement, it's not an illusion.
Yeah, and so it might be the case that might be an interesting case, like the size weight illusion, where it might be the case where the illusion comes from asking the wrong question, right? So the size weight illusion, the size weight illusion isn't definitively about throwing, but it's at least a little bit about throwing, right? Mm-hmm. And about the throwability of objects. But the main thing about the size weight illusion is that it's cast as a misperception of weight, right? You give two objects of the same weight but different sizes, and the bigger one feels lighter, right? Mm-hmm. And so it's a misperception of weight is one way to frame it. Another way to frame it is that weight is not what you are currently perceiving, that you are experiencing a size-weight relation probability, movability. It has to do with the inertia and the movability of the object. So what we're actually detecting as an affordance property that is a relation between size and weight. And it's not that you're perceiving weight and incorrectly taking size into account. It's that nothing in you is measuring weight at all, and everything's moving, actually perceiving the affordance property of movability that has to do with the inertia. So again, one of the other things about illusions is sometimes it's only an illusion because it's the psychologist's fallacy. Well, I asked you to perceive the weight, and you didn't, so therefore you made a mistake. And the psychologist's fallacy is to think that just because I asked you to perceive the weight, that you were in fact able to do so.
Yeah. No, that's what it's same with any kind of experiment. When I tell you to judge this, how do you know the person is judging that? You have to create.
So one of my favorite Gibson quotes is that he just says, "If I am right, then all previous experiments done by psychologists have been useless." It's a great. It's just such a Gibson line, but he has a point, right? Yeah. Because if he's right and affordances are the primary sort of object of perception, then an experiment, all these careful psychophysical experiments about weight perception were literally pointless, right? Because you're asking the system questions, and it's trying to give you an answer, but it's giving you an answer based on what it actually knows how to do, which has nothing to do with the detection of weight, right? And it's like, and so who's at fault there? It's not the perceiver that's falling into a trap. It's the experimenter who has fallen into a trap, right?
Yeah.
It kind of goes back to that thing right at the beginning of the book where he talks about look at Euclidean geometry and things, and like why would we see things in centimeters and meters? Like why would that be?
And Gibson has a really deep point that he makes it somewhere. I can't remember where he makes it, but he just identifies. Look, one of the key insights here is that the objects of perception are themselves a topic for empirical research by psychologists, right? And he's kind of going, we actually can't take it for granted that just because it seems obvious that we perceive weight, we actually can't take that for granted. It's an empirical question. And so you have to ask the question. And when you look at the psychophysical data, wow, there's all this, we're terrible at perceiving weight. Well, maybe that's because we're asking the wrong question, right? And it's quite a weird insight, but it's a pretty central one that actually, and this then becomes, well, okay, if you want to know how people go about throwing a ball or hitting a target, then you actually have to investigate empirically the objects of perception rather than making educated guesses about what you think people are perceiving in order to, just because of the physics, because the equation, right? You get the equation of projectile motion, and that tells you some things, but that doesn't actually tell you whether or not that's what the person's interested in. And actually, if you run the experiment, the person's not interested in that or that or that, but it's interested in a higher order relationship between those things that is an affordance property. And so it's an empirical question what to study. And effectively, that's what illusions mostly are. It's somebody goes, well, I tried to get you to do this and you got it wrong. So, haha, I tricked you. And whereas the actual answer, where Gibson would just go, actually, no, you just ran a really dumb experiment. You asked the wrong question.
You measured the wrong thing. Yeah.
Sorry, dude, that's on you, right?
Yeah. No, and all the body perception kind of stuff, same thing, right? Yeah. If you ask, do people perceive the size same, then they're wrong. But they perceive how hittable or something or how catchable, then it'll for sure. So
so there's intention in there as well, isn't it? Which takes us right back, I think, to like why we move in the first place, and this idea, and even Eleanor Gibson's work on that we start to perceive the world when we move with intention within it. Yeah.
You get a little bit of hints everywhere once in a while. Like even Helmholtz talks about active exploration a little bit. So there was the ideas there. People just didn't kind of go as far as Gibson did with them.
I got the impression when he was when he alluded to about in Helmholtz, when he's like, oh, we've got this, like starting to get something that seemed nice and tidy, and then it's like, oh, what happens when like the muscles in your eyes move, and then your head moves, and then this moves, and it's like, oh no, that's really complicated. And it was almost like they thought, oh no, that messes everything up. Whereas I think Gibson just went, oh, that maybe is where we need to start.
Yeah, and look, I still think this is one of the most important things about Gibson was that he ran those kinds of experiments, all the weirdness, and didn't stop asking questions. Like that's one of the reasons why he's actually quite a special guy, right? Like, and why it took so long to find out is that he kept going, that's weird. Why can't I get that to work? What happens if I do this? What happens if I do this? Oh, I did all of the things and none of it worked. And he was also able to just go, right, clearly I'm doing something wrong. The data, like he was paying attention to the data. Like I think a lot about the fact that kind of curiosity and that willingness to accept the fact that you've been doing things, asking the wrong question and taking the hint was it's not unique to him, but it was one of the really key things that made him capable of creating an alternative, right?
Yeah, I think there's some good points there. And Gibson just didn't rock up with this theory, right? He developed it over a lot of time trying to do it Helmholtz's way, understand perception from slant to whatever, sir, Helmholtz's way, and it didn't work. Yeah, I sometimes I find really, really intelligent people are kind of deliberately dumb. By that I mean they question, like, what does it mean to perceive? Like they take other people, just assume and move back. Smarter people move past quickly. They's like, what is that? What's the job of the perceptual system?
Yeah, exactly.
That's where he went back to, because he couldn't, which is right, very profound. Yeah.
And then didn't find a satisfactory answer and then kept going. That's the other thing, right? Like just kept asking the annoying questions and followed them where they went. It's, because it's, again, with Helmholtz, I'm so struck by the fact that he is so clearly, trapped is a slightly rude word, but he's so clearly fully constrained by the Cartesian program that he can't even see the constraints. And everybody we've talked about so far has just been so fully constrained by it in the sense of and they're constrained by it in a sense of necessity, right? Like, how else could, like, this has to be the basic raw material. What else could it possibly be, right? Which is another good question, right? Tim Van Gelder, his paper about what steam governors and dynamical systems versus computational systems is just to ask the question, you think computation is great, but what else could it be? Well, actually, it could be this one other thing. That's another really important question. What else could it be? And all these people seem to be, and look, this is being filtered through Turvey's lens, obviously, but also I trust Turvey to be giving these people a fair shake. None of them are asking what else could it be. They're all going, okay, it's this.
Yeah. How can I make it better? Yeah.
Right.
Yeah.
And you have to do some of that, but you also have to notice when it's not working, right? Yeah.
One of the bits that struck me goes back to, and I know it was something, around when we think about indirect perception and having all that complexity. How do we ever manage to do something with why is it so reliable? And I think it's page 184, I think, from my notes, that he talks about the fact that the question is, how can phenotypic behavior or structure be so contingent on apparently minor experiences like eating bugs, when you're little, and yet still be so completely robust.
Yeah.
And then he starts, for me, he has to start talking about these. You have these attractor systems, aren't there, within this nested complexity but you've still got some really stable perceptual motor attractor states that something might be later, or there might be small bits, but actually fundamentally we don't all crash our cars all the time and miss the ball and don't develop. It was
but it's it's repetition without repetition, right? It's the idea that there isn't, it's the truth of redundancy, right, in the motor system. Like that's just a fact we all have to kind of accept when we're studying how motor control could possibly happen. That's one of the basic rules, is redundancy, which means repetition without repetition. And in some ways, this is just that fact showing up again somewhere else.
Yeah.
Right?
Yeah. I think there's a lot of important parallels between the information.
And I don't think those parallels are accidental. I actually as I think it's all reflecting the same basic sort of, the truths of dynamics and evolution and how these things work, right? So you can't simply program up the correct response. So on 184, he's making the distinction between a program-driven solution and an execution-driven solution.
Yeah.
The essence of uncontrolled manifold analysis and all that sort of stuff is that the solution emerges during the execution rather than happening in real time. And the hypothesis is that it could not possibly be any other way.
Mm-hmm.
So just as you were bringing that point out, it was I'm in uncontrolled manifold land in my head, and so it was just thinking about. But it's there.
Organization again. He's almost like setting up self-organization, isn't it?
Absolutely.
You start to notice where he's like dropping bits in.
Yeah. You notice that knowing the motor side of things. We talked about time scales, different. A concept we usually talk about in motor system.
Yeah.
I think they're fundamental properties of the whole system. That's why they're showing up both.
Yeah. And the other thing I was thinking, this is completely unrelated. I remember Ed Baggs on the podcast with me saying, "Oh, we only got to chapter 10," and it's not Vincent. How do you pronounce his name? I feel terrible. Yeah, he still gave me chapter 10, and I was like, I've got to chapter 12. I was like, that's very tough.
It's paid off. I really enjoyed these last couple of ones. They're kind of.
I did. I was thinking that it's starting to enjoy them. It feels like all that hard work's paid off.
Mm-hmm.
I mean, we've done a lot. We've covered a boatload of ground.
So next we're getting into the gestalts, right?
Right.
Yeah.
Which I've read this before. It's been a while. I can't remember how it goes from here to there. I guess I could see a little bit. In historical, I know the gestalts are next in the timeline.
Yeah, right.
From unconscious inference to gestalts is a little bit of a.
I just know about gestalt psychology, but only a little bit from undergrad. That was a long time ago. So I'm looking forward to that. But yeah, it does feel like we're starting to get into. He set up a lot of stuff that needed to be set up, and it feels like it's starting to get more interesting.
A little bit. Yeah.
Well, and the other thing I have to keep reminding myself is that these are lectures on perception, not lectures on ecological psychology, right?
Yeah.
So it's an exploration of the problem of perception, and the problem of perception has been engaged with for hundreds of years, and in multiple different ways, and it's important to engage with all of those, and try to learn the lessons from all the engagement and the things that worked and the things that didn't.
Yeah, and I think you did it. You're right. We gave a good due to Helmholtz in this chapter. Obviously, like we've tried to emphasize, this is one of the most important theories there is, and it still endures today, right? In various forms.
Yep. Open any sensation perception textbook, you're going to learn about the doctrine of specific nerve energies.
Yep. You're going to learn. Unconscious inference is the basic idea of. That's not what we call it anymore, but any kind of model that has a Bayes in it. That's what it is. Yeah. Well, cool. That was good. That was. I think we sort of went random directions, but that's the fun of it. Yeah. So I think we'll wrap it up there.
Cool.
And we'll see you next time. We don't know when that is coming soon. We're on the summer schedule right now, so we'll get it back to the gestalts. Where are we heading after that?
I don't know. What are we doing next?
So we got a couple. So we'll do 2 gestalt chapters.
Actually, we got.
Then we're getting into the computation representation.
Yeah,
excellent.
And then finally, we'll get into the ecological. Finally, get into ecological. Obviously, threat coming through all of the book.
Well, thank you.
Yeah. Thanks, everyone.
Guys.
I enjoyed that.